As Team Panipat, we went beyond physical observation. We analyzed official municipal documents, reviewed government portals, and studied technical reports to understand how modern water management system functions and where improvements can be introduced. This video highlights our on-ground observations, infrastructure analysis, and data-backed insights into water distribution, treatment efficiency, and sustainable conservation practices. Our goal is simple to bridge the gap between traditional water systems and smart technology driven solutions.
I'm Sastra Kura representing our team Panipat from BYT College of Engineering for Women. We have chosen the problem statement ID3, which states Smart Water Pressure Management for Equitable Water Supply in Solapur Municipal Corporation. The existing water distribution infrastructure operates across multiple elevation zones and service areas, yet it continues to face systematic inefficiencies. These include uneven pressure distribution, high levels of non revenue water, delayed leak detection and manual valve operations, and limited real time monitoring capabilities. While the physical pipeline network exists, the absence of integrated sensing, automation, and centralized analytics restricts proactive governments and sustainable resource utilization. Our primary objective is to transform the conventional water supply framework into a smart, pressure balanced, data driven management system. The clarity on the problem gives us a better solution. Thus, we have divided the problem statement into six main objective strategies, and we're going to state functions as well as its constraints in the further video. The first main objective is the pressure distribution system through scientific zoning, or it is nothing but pressure zoning system, which we're going to further discuss in the video. The second one is how we're going to tackle or how we're going to measure the non-revenue water. And third one, it is about establishing a continuous real-time monitoring system or an IoT-based system for showing all kinds of pressure maps or analytics which are further going to be used in a long-term infrastructure planning. The fourth one is about smart valve operation so that it reduces human errors. Taken four main objectives that we're going to implement and discuss in the further video. Now, to achieve all these objectives, we obviously need its operational and functional requirements. So, these sensors continuously measure the flow rate, pressure, water, etc. But we also need processing units such as microcontrollers or a real-time anomaly detection. But how are we gonna get all of this information, that input and output data? The whole thing is done through that IoT based system, which is a reliable transmission through Wi Fi with GSM backup support. A cloud based analytics. So, the cloud based analytics we are going to use here is ThinkSpeak, a simple beginner level tool which actually can help a lot of people to extend this. So, basically, we take the data, it's basically a backup storage where it can, all these cloud storage systems hold centralized dashboards, graphical reports. All of this data is being stored at a place, at a cloud storage. So, thus, every material has its functional or operational abilities. Now, to create this framework for all the citizens, or to create this interface between the government and its citizens, this is a platform that connects both the officials and the citizens.
Solapur's water network can be divided into multiple pressure zones to manage differences in elevation and ensure balanced supply. The city can be organized into approximately 4 to 8 main pressure zones, which are further divided into 20 to 40 district metered areas or the DMAs. Each DMA can serve around 1500 to 3000 household connections. At the entry point of each DMA, an isolation valve can be installed to measure and control the incoming water supply. For low lying or low elevation areas where pressure is high, pressure reducing valves or the PRVs can be installed to regulate excess pressure and prevent pipeline damage. To simplify monitoring and visualization, each pressure zone can be color coded similar to a metro line system. For example, blue zone, red zone, and green zone. This color coded system helps officials quickly identify pressure status and manage the distribution efficiently.
Our IoT-based smart water pressure management system has two secure logins, official login and customer login. The official dashboard provides real-time pressure maps using GIS data, and it identifies high-risk pipeline zones, and it supports maintenance tracking. It also enables timer-based zone-wise scheduling and automatic rerouting through an automated valve system, and an instant SMS alert system notifies plumbers during faults for quick action. The system also stores historical data and is AI ready for predictive maintenance and future expansion. The customer dashboard offers water usage analytics, an online billing system with dues tracking, and a real-time water quality updates, and also a complaint submission feature. Overall, the system ensures efficient water distribution, transparency, and faster issue resolution.
Our project represents an IoT enabled intelligent water distribution and leakage detection system designed to enhance operational efficiency and reduce non revenue water losses. So, the process begins with a continuous sensor data acquisition where flow sensors, pressure sensors, and water quality sensors are deployed across the pipeline nodes to monitor the pipeline parameters in real time. These sensors can generate pulse and analog signals that represent flow rate, pressure intensity, and water quality indicators. We use the ESP32, which is a low cost, low power microcontroller with built in Wi Fi and Bluetooth that converts those signals into understandable values like how much water is flowing and how much pressure is in the pipe. A comparative inlet outlet flow analysis is executed to detect volumetric, pressure, and quality discrepancies. If the system notices such issues, it immediately flags it as a problem, and then the data transmission is carried out via Wi Fi connectivity, ensuring uninterrupted communication. And then the data is securely stored and visualized on the ThingSpeak cloud, a platform where the officials can monitor everything in real time and take a quick action.
Water distribution is a constant struggle. Some zones face low pressure and dry taps, while others deal with wasteful excess. Aging infrastructure and manual operations lead to massive water loss and zero visibility into the system's health. Introducing Panipat, an AI powered smart water pressure and equitable distribution system using IoT sensors. AI driven dashboard monitors the city in real time, instantly detecting anomalies and pinpointing leaks with precision. The system responds automatically, redirecting flow and alerting repair teams before a minor leak becomes a major crisis. With geotagged alerts, repairs are faster than ever, restoring flow and saving every precious drop. Smart water, equal distribution, and sustainable future for all. That's the power of Panipat.
The objectives, its functions, let us try to understand the constraints. So, technical limitations such as sensors, calibration accuracy, or network dependency in remote zones, which is one of the most challenging problem. And the environmental durability is also one of the factors that comes under technical limitations. Now, financial constraints include phased budgeting or GSM cost or the sensor costing, the aging pipelines replace costment, and everything comes under financial constraints. And operational challenges such as that the things that I've just mentioned, such as aging pipelines, resistance to digital transition, and initial learning curves require structured change management. So our main goal is to convert a traditionally manual and reactive distribution network into a proactive, digitally controlled, economically optimized, a citizen transparent water management model. This initiative represents a strategic step toward a sustainable urban infrastructure and smart municipal governments.